So guys, as I have promised that I am going to give the best test solution about GATE Aerospace, all the questions in detail and not only the solution part. I will also give you some related information which is going to be very amazing about that particular question. Okay, so see here, this question I have taken down properly and all the interesting details what you should know about this question and after this question, so that you can be safe side even though there are some twist in the question, or what kind of other expectations we can keep, we can have for this particular topic. Okay, so see here, actually before discussing the question, I am going to tell you that you should know few important formulas. What is that formula? Let's understand that. And before that, you should know this question what I have taken here, particular question. Already you know the question, so first I'll tell you the toughness level of this question is actually moderate. Why moderate? Because this is very popular question, and last year before GATE exam I have uploaded very similar problem, and fortunately it was public on YouTube. So many of you, even though you are not running, you are not CL student, you are not in concept library, if you are following my channel, so many of you may have cracked this year GATE problem. I'll show you which problem I'm talking about. So you can see my screen here, you can clearly see this question, you see this question. Okay, you can see here I have a playlist. You can see this playlist, aircraft structure for GATE. You can see the playlist name here right at the top. So in this playlist all the important questions already I have discussed last year before GATE exam, and this was very similar question from that. So just let's understand what is this. So first thing, if you want to solve this question in GATE exam, it is actually a lengthy problem, and lengthy problem means, because if you understand everything in detail, because see last year in my classroom programs these kind of questions I have given, and not only this, very standard formats, highly possible formats we have discussed and I have given in my study material also. Okay, so students who are in my live program, students who are in my video course program, students who are in my study package program, they all, like I have 20 different types of programs for GATE aerospace preparation, they all are totally aware of these kind of questions, how to solve. Okay, now this solution I am creating so that even other students who have not joined me, even they can have a very detailed knowledge in depth about and these kind of questions related. Okay, so actually this question they have asked for cantilever beam, but same concept we will also apply if this is cantilever beam and this is propped cantilever beam, but same question they can ask in case of fixed beam as well. Okay, and in case of continuous beam as well. So you just go through the concept and all the formulas and everything already I have given you. If you are my classroom student, then everything is there, and in these kind of questions I have also asked in test series. So many standard cases what I have done, what I have discussed in class assignments, and test series is loaded with these kind of questions. Very similar question already I have discussed and uploaded on YouTube, which is public. You can check in playlist. Just now I have shown you. Okay, now let's understand all the important formulas first. So some standard cases from my classroom study material I am giving here. So see, suppose this is a cantilever beam and at the free end you have applied any load P, and suppose this length is L. So in that case, when the beam will bend like this, you will be having slope at this point. That slope formula is PL square by 2EI. Okay, and at any distance in this direction you will consider here x is equal to 0, and when you will reach here x is equal to L. So at any distance x, if you want to find out deflection, then you will be using this formula, px square by 6ei, and in next bracket you have 3l minus x. Okay, now next part, suppose you want to find out delta max, means maximum deflection. So maximum deflection you already have at the free end always. Okay, in case of cantilever, so here you got your maximum deflection, that is nothing but PL cube by 3ei. So this is one formula. So in this formula, this particular and this particular equations are important for us. Okay, now next thing, if load is not applied at the free end, if load is applied at any distance A from the fixed end or at any distance B from the free end, in that case what will be your slope? So where are we talking about the slope? Slope is like when the beam will bend like this, so it will not bend actually like that. So like this much portion of the beam will bend like this, and after that remaining portion will be totally straight. Okay, so exactly at this point when you are calculating the slope, this slope formula is PA square by 2EI. A is this length, P is the applied load here, and EI is the flexural rigidity. Okay, but suppose you want to find out deflection. Deflection means suppose this was the beam and it is deflected like this. So this length is A and this length is B. So inside anywhere, if you want to find out deflection here, then you will be using this formula of deflection. Y is equal to px square. You can see px square 6ei 3a minus x. Okay, 3a minus x you are using when you are calculating the deflection like this side somewhere. From here you will consider length L. Okay, here 0 and here length L. So this side. But if you are looking for the deflection this side, then you will be using this formula. Okay, so PA square by 6ei like this. So I have given you limits here, like 0 to A you will be using this formula, and A to L, like from this A to this L total, you'll be using second formula. Okay, now maximum deflection is always at the free end, so you'll be using this formula. Now see, I will read the question and after that I will explain the further part. So now I'm going to read the question. Understand this. So first thing in this question, we are solving 2022. In this question, this much statement was not of any use. Okay, I will read what is this. Given the tip deflection means delta max, and tip slope means theta, for a tip loaded cantilever. Tip loaded cantilever means load is applied at the tip, means if this is the cantilever, so load is applied here. So I have discussed just now all the formulas of length L are NL cube by 3EI, NL square by 2EI. Actually everyone knows these two formulas. They are standard formulas, even they are not mentioning, because one more thing, the entire formula is not useful for us, where N is the tip force and EI is the flexural rigidity. Why I am saying this is not useful for us? Because whoever is preparing for GATE aerospace exam, all the students are already remembering all the standard cases. Okay, whether you study in any coaching center or you do self-study, you have to remember all the standard cases. There are 19 different standard cases. Okay, all the 19 different standard cases you should remember. Okay, and I have given all the cases to my classroom batch students. Now come to the main content of the question. A cantilever, I'll change the color. This color I'm not liking it, so I'll use this color. Okay, a little bit more dark, we'll go for this. A cantilever PQ of rectangular cross section is subjected to transverse load. So get everything in detail. Are you aware of cantilever beam? Yes, everyone is aware. Do you understand what is the meaning of rectangular cross section? Yes, you know. Means if you have a beam like this, the cross section is actually rectangular. Why rectangular cross section? It will help you to calculate moment of inertia. That's why this information is important. Anyway, for this particular question, moment of inertia will get cancelled out. So even though you don't know the formula of moment of inertia, does not matter. But because they can ask similar question where you have to find out in future. So moment of inertia formula you should remember. Now, at its midpoint, so load F is acting at its midpoint. I will show the diagram. Now two different cases are given. Two cases are considered as shown in figure. I will show you the figure. In case 1, the end Q is free, and in case 2, Q is simply supported. So you can see here, this is end Q which is free in this case, and this is end Q which is simply supported in this case. So when cantilever beam is simply supported by a roller support, we call that as propped cantilever. Okay, propped cantilever. I hope it's clear. Propped cantilever, a special variety of beam which is indeterminate. This category is indeterminate category. Why? Because we have 3 forces, 3 reactions here and 1 reaction here. Okay, 1 horizontal, 1 vertical and 1 moment, and here 1, so total 4. But we have equilibrium equations only 3, because 4 is more than 3, so we cannot find out the 4 variables using 3 equations. That's why this beam is a special case of indeterminate beam. Okay, but this beam is very simple beam. Anyway, because see guys, actually you are solving GATE previous year question paper. It means what? Already we are expecting that whatever topic you are solving, in that topic all the standard formulas you know. And no problem if you don't know, already I have explained in this. So those 2 formulas you note down, and believe me, you will thank me in future, because very soon in 2024 or in 2025 they are further going to drop these kind of questions. So that formula you please note down. Okay, and don't worry, if you are in my coaching center already, whatever I have taught, whatever I have given, that is sufficient. Okay, now the ratio of magnitude of maximum bending stress. So actually this question needs the concept of deflection also and bending stress also. Okay, so that's why the toughness level is moderate, I will say moderate. So why I'm saying moderate? Because these type of problems we used to discuss in our live class. So everyone from aerospace department, mechanical department, civil department, XC, they all will be solving these kind of questions. They all will be having, because if you take any standard book, you will be having these kind of questions. Okay, so it's not like this is very hero type question. No, 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 no. It is our general practice question. Okay, so that's why I'm saying level is moderate, because if you're attempting for GATE aerospace exam, everyone is expecting that you have already done these kind of problems. So that's why this question is not that tough question. Okay, now next part is we have to think about the bending moment. So bending moment, already we have solved some previous numericals of this 2022. So you can see how bending chapter is important. Okay, so we have to find out actually the ratio of magnitude. So focus here, magnitude. Why we are saying magnitude? Very soon I will explain. Of the maximum bending stress at point P in case 1 to that in case of 2. Okay, I'll come to this part, and now let's go into the detail of the question. So see guys, this is the question given. You have cantilever beam. Okay, because of that what will happen? Because of that at the P end you will be having some stress because of bending. So that stress formula, sigma is equal to m by I into y. Understand, when they talk about maximum, because here they have given you maximum means, you can see if you talk about the cross section, if you look from this side, the cross section is actually rectangular. So this is your neutral axis. So at the top layer only your sigma is going to be maximum. Okay, so in this case also and in this case also y value is constant. In both the cases y value is same. Okay, so if you say at point P you have sigma 1, and in this case at point P you have sigma 2, so when you will take the ratio of sigma 1 and sigma 2, so y value will get cancelled out. And one more thing, your I value will also get cancelled out. Why? Because this is also rectangular cross section and this is the same beam. So again I value is going to be, because I value is always using this formula. If you remember what kind of concept I have taught you in the live classes, how to calculate I. Also I does not matter on the loading condition. I matters only on this cross section. So cross section is same in both the cases, so I value will also get cancelled. So it means what? This question they have framed on the basis of sigma proportional m. So you can see concept is very clear. Sigma 1 by sigma 2 we have to find out. In this case sigma 1 and in this case sigma 2. It means the ratio will be nothing but ratio of m1 and m2. So at this condition here what is your m1 value and here what is your m2 value. It means what? Meaning is, I'll explain this. Suppose here you have cantilever beam, so you are loaded with this force. So at this point how will you calculate your bending moment? So bending moment is nothing but force into distance. Correct, this distance you can find out bending moment. And one more thing, because this is coming downwards, so it will be hogging. So hogging means negative bending moment you will be having. Okay, now next part, when you are applying load from this side, then it will take the beam like this, then positive bending moment, right? Okay, so because of this load you have positive bending moment, because of this load you have negative bending moment. See what I'm saying? Because of this load you have negative bending moment, because of this load you have positive bending moment. So this is sagging case. Okay, anyway, so I will focus one more thing, because in this case, like in the case 1 you have load here, so simply you multiply the load with the distance, you can find out your m1. But in second case you have load here and propped cantilever here. I see, understand the logic. In second case you have wall here, you have load here, and you have this support, extra support here. So this support I will remove, and what I will put there, I will put equivalent reaction there. So suppose this reaction is R and this force is F. Okay, so what will I do? Because of this force I will write the bending moment. This length is L and this length is L given in the question actually. So F into L I will do, and because of this R what will I do? Minus R into 2L. But the point is we don't know this R. So for that I'll be using the concept how to calculate reaction forces. So see guys, when your teacher is teaching, if you are in my coaching center, then already I have taught you how to find out reaction forces for different cases, right? For fixed case, for I have given you direct formulas also. So I am expecting that you should be giving me direct answer of reaction force the way my students are giving. But if you are not able to give reaction force, then within 1 minute you should be able to calculate the reaction force. So you should know how to calculate reaction force in this part. Okay, so already I have taught you, but I have given you standard cases. So this question is from one of those standard cases. So all the concept library student, they will apply the direct formula because they know what is the formula for this. Because but only that student cannot apply the formula who have forgot because of memory. Okay, now next part, how will you calculate this R? So for that, very simple logic. You see, simple logic is, suppose you have a load here, that load is F. Because of this load, this point will go this much down, so that I will say as del max. Okay, so this will be stretched like this and then a straight line. So this del max I am getting because of this load. But imagine if you are keeping one extra roller support, roller support, because of this roller support you are getting one extra reaction here. So exactly at this location there will not be any deflection. It means, what is the idea? Idea is very clear. This force F is giving you this deflection. It means what? Now you don't see this as a support, you see as a load, that there is one load R, and this load R is giving you equal and opposite deflection, which is exactly equal to the deflection given by this force. This deflection is coming downward, del max, because of this force, and this R is giving you again same deflection. That's why this point is not going anywhere. This is how we draw FBD, free body diagram, correct? So it means what? Deflection because of the force and deflection because of the reaction we will equate. Then we can find out the reaction force, value of the reaction force. Like see here, this force is F and here this force is R. Idea is very simple, very simple idea. At this location you will find out del because of F and equate that with del because of R. That's all. And of course they are equal and opposite, that's why this point is not going anywhere. Why are we doing this? Because this term will contain force F, but this one will contain force R. Okay, so see here, this case you should understand in this way, that you have a cantilever beam and here you are applying any load R. So because of this load at free end, what will be your deflection upward? So that deflection formula I have taken here in detail. So that's what I have given you. See here, when you have force F applied here, then this length is L, this length is L. So till here it will bend like this, then it will go like this. So this deflection formula will appear here. This is del max. Okay, so from where you will calculate the del max formula? So for that I have given you a standard case here, that if load is acting somewhere here, then you have maximum deflection formula here, you can see. Okay, this deflection formula you will use, but in terms you will substitute the variables. So you can see force is F, the applied force is F, total length of the beam 2L, so I have written here 2L. Okay, and this A value, which is like this is L square. So you can clearly see PA square by 6CI, PA square by 6CI, 3L minus A, so 3 into 2L, because L is nothing but the complete length, and L means this A is equal to L. So when you will solve this, you will be getting 5FLQ by 6EI. Okay, done. This part over. Now this part I was talking, when reaction will act from the downward, that time it is a like free end condition, which is very easy condition. So this is the only formula they have given in your question statement, that is NL3 by 3EI. Free tip, you can see, tip loaded cantilever, NL3 by 3EI. So this is not a big help. They have not given you any kind of help. Okay, this formula anyway everyone knows this formula. So it's not like they have given us, okay, we are giving you the formula and all. No man, no, it is not a big help by gate authority. Okay, so don't worry, because of this R, whatever equation will come, we used to remember in our classroom programs PL3 by 3EI. Actually some people remember this as WL3 by 3EI, some people remember as FL3 by 3EI. There are like different teachers, different notations, different books, different notations. So PL3 by 3EI we used to remember, totally clear. So this value I will substitute here. This L is nothing but like L and L, so 2L, so 2L I'm writing here, and 3EI as it is. When you will solve it, this will come. Now see, equation 1 is that deflection which is coming because of the load. Equation 2 is that deflection which is coming because of the end reaction. But finally this point is not going anywhere, which gives you idea that this deflection and this deflection is same. So if you remember that when I was teaching in class, that time I told you by equating deflection we used to find out reactions and we solved numericals. So this is the same numerical. Okay, same numerical. And last year also I have given these kind of numericals. So we got our R value. Once the R value is done, that's all, question done. Because now we can focus on the concept of maximum bending stress. So see here, because cross section is given as rectangular, so you know this will be your neutral axis. And once the neutral axis is defined properly, then we know in this direction you will be having y. So they are asking for the maximum, so maximum means y will be this much, so at the top fiber. So in both the cases we have to go for maximum. Okay, it means y value is constant. So when you will take the ratio of sigma 1 by sigma 2, y will get cancelled out in both the cases. Okay, I will also get count, so it will be remaining with m1 by m2. Okay, now the point is how will you calculate m1? So for that, see here, mod is very important. Why mod is important? Because they are saying us in the question that there is a keyword here. The keyword is, I will tell you, the keyword is magnitude. That's why I'm using mod. Why magnitude? Because in case of hogging, negative answer will come. In case of sagging, positive answer will come. Okay, but in the exam hall they are saying us to write down round of one decimal place. Okay, so anyway, you got the idea. Now you see how I have done the explanation. M1 value is nothing but for the first case. So first case is very simple. Your force is here. Okay, this force is F, this distance is L. Correct. So this force will come like this. So this will be your hogging. Correct. In case of hogging we write negative sign. So this minus FL I am writing because of this force. So I am writing minus sign. But anyway I am using mod. Why mod? Because it is given in the question. Now see, because of, now in the second case M2, so M2 is because of this force R. M2 is because of this force R. Actually see, not R only, because in second beam you have load here also and load here also. Here load is F and here load is R. So that's why you have this term also and this term also. Because of this R, this beam will go up, so sagging is so positive, and this length L, total length will be 2L. Why are we multiplying length L and 2L? Because always remember we have to calculate at the fixed end. So from this F, this distance is L, from this R, this distance is 2L. So at the fixed end we have to target the moment. So I hope totally clear. That's all, nothing is remaining. FL here minus FL here, 5 F by 16, you can put the R value. This R value is this. Okay, and the 2L is as it is, this 2L. That's all, job over. FL will get cancelled out. So we are remaining with the numerical part, and finally we are remaining with 8 by 3. You do by yourself, your answer will come 2.67. So you can see, now I am going to tell you the beauty, because till here you have watched this video, so definitely I should give you one beautiful question as well that we can expect in the upcoming years. That question will be, see here, they can give you this question that they have applied a bending moment here, this thing, and they have applied M like this, concentrated moment. Okay, and they can ask you by applying prop cantilever, and they can ask you what is the reaction force here. They can ask you what is the reaction force here after applying the prop cantilever. Okay, they have applied moment here. So what will you do? Idea is very simple. Because of this M, what will be deflection at the free end, and because of this R, what will be deflection at the free end? Both deflections you equate and you find out the value of R. That's all, job over. Okay, let's see another solution again in the same amazing and properly explained way.